Can you measure this line exactly? You might say 10 centimeters. But what if I told you that's wrong? Not even the most precise instrument in the universe can measure it exactly. And the reason why will blow your mind. Stay with me. Before we dive into the mind-bending stuff, let's understand something fundamental about our world. Look around you. Everything falls into two categories. First, discrete things. 3 apples. You can count them. 1, 2, 3. Then, continuous things. Water, a distance, time. Cut a rope in half and you still have length, just smaller amounts. The identity stays the same, no matter how many times you divide it. A fraction is like a microscope for numbers. In a fraction like 73 over 100, the bottom number, 100, is how fine your scale is. The top number, 73, is how many of those tiny pieces you have. So we can measure anything now, right? Just make the denominator bigger and bigger. But here's the crazy part. Between any two fractions, no matter how close, there's always another fraction. You can zoom forever. Fractions are infinitely dense. Surely they can measure everything on a continuous line. Nope. And this is where your mind is about to explode. Alright, let's play a little game with this simple square. Each side is exactly 1 unit long. Neat, clean, easy to measure. Now let's connect these two opposite corners. How long is this diagonal line? Sounds like a school question, right? The ancient Greeks thought the same thing, and they had a smart trick called the Pythagorean theorem. It basically says, if you know the sides of a square, you can find the diagonal using a bit of geometry. And the answer they got was something called the square root of 2. Okay, cool name. But what is it really? Here's the weird part. They tried to write it as a simple fraction, but nothing worked. 3 halves, nope. 7 fifths, still not right. 99 over 70, closer, but still not exact. No matter how small or clever the fraction, it never hit the bullseye. It was like trying to fit a round peg in a square hole. Close, but never perfect. This drove ancient mathematicians crazy. They believed everything in the world could be expressed in whole numbers or fractions. But this diagonal, this innocent little line, said, I don't play by your rules. And when they looked deeper, they realized this diagonal's length was a number that goes on forever. 1.414213562, and on and on and on, never repeating, never stopping. This was something completely new, a number that's real, measurable, but not made of fractions, a number that lives in the infinite gaps between the numbers we know. Imagine their shock. The world they thought was perfectly logical suddenly had hidden cracks of infinity running through it. But today, we see it as something beautiful, proof that the universe isn't simple or neatly packaged. Even a basic square hides mysteries deeper than infinity itself. So back to our original question. Can we measure anything exactly? Your ruler says 10 centimeters. But zoom in. Is it exactly 10 or 10.0001? Every physical measurement has uncertainty, but never exactly 10. It's like this. Mathematics gives us the perfect target. Reality gives us arrows that always land near it, but never exactly on it. And you know what? That's okay. Engineers design bridges with tolerances. Scientists report measurements with error bars. We've learned to work with uncertainty, not against it. If this broke your brain in the best way possible, hit that subscribe button. Next time, we'll explore how equations capture the patterns of reality and how machine learning does the opposite. Drop a comment. What would you like to understand mathematically? See you in the next one.